Welcome back, grade 8. In this video, we're going to continue from the last video about product of power laws. This is product of power laws part 2, and this corresponds to section 8.2 from the textbook. Let's recall from our last video that if we had 4 squared times 4 to the power of 3, this would give us 4 to the power of 5. Because we have that general rule that if we have a to the power of m multiplied by a to the power of n, then it would give us a to the power of m plus n. So we're simply just adding those exponents. So we have, in this case here, it was 4 to the power of 2 times 4 to the power of 3. We got 4 was equal to the power of 2 plus 3, which is why we got 4 to the power of 5. And we can also recall that if we had, for example, a raised to the power of 5, all of that raised to the power of 5, well, that was going to be simply a to the power of 25. Because we had that power to a power rule that told us that a to the power of m, if all of that was raised to the power of n, then that was simply just going to simplify to n. A raised to the power of m times n, or just a raised to the power of m n. So we can see in this case we had a 5 times 5. So a to the power of 5 times 5, which is why we got 25. In this video, we're going to continue looking at product of power laws, but when they're in a slightly different form. So let's look at these two different examples that are in a slightly different form, and we want to think, how can we simplify these? So we have 2x in parentheses, all raised to the power of 3. So this means that 2x has to be multiplied by itself 3 times. So we can have 2x is being multiplied by itself again, 2x being multiplied by itself again, 2x. And now we can see that in between the 2 and the x in here, what we don't see is a multiplication sign, right? Between that coefficient and that variable, we have a multiplication sign that we're not showing. So essentially, it's like saying 2 times x times 2 times x times 2 times x. Now, when we have everything multiplied together, we can just multiply things that are like. Well, what's like in this case is the 2 and the 2 and the 2. 2 times 2 times 2 makes 8. So we get 8. And we just learned from before that if we have x times x times x, well, that's going to give us x to the power of 3. Looking at example 2, we have 3xy in parentheses squared. So that means we're doing 3xy multiplied by itself another time. So we've got 3xy times 3xy. Everything is being multiplied with each other. So because it's being multiplied with each other, we can simply just multiply the things that are like together. So 3 can be multiplied by 3, and we get 9. And we can do x multiplied by x, and we get x squared. And we can also do y multiplied by y, which will give us y squared. A common mistake made by this kind of simplification is that when they have an example such as 2x squared to the power of 3, a lot of the time students will see that the exponent is being raised to another power. So we see that we've got a 2 raised to the power of 3 here. So simply, when they simplify that, they say 2x, and they have a power to a power, so 2 times 3 makes 6. And they do 2x to the power of 6. But the thing is that this 3, this cubed, is applied to everything inside of the parentheses. So we really have to be thinking that it's 2x squared multiplied by 2x squared multiplied by 2x squared. And if we simplify everything there together, we're going to get 8x to the power of 6. So this part here is where we have to watch out. So this is a power to a power law. So we have these two last examples. We have 3a in parentheses raised to the power of 2. So again, this 2 is being applied, or this squared is being applied to the 3, and it is being applied to the a. So we have to think 3 squared makes 9, and we have to think a squared makes a squared. So for this one, the second one, we have 2a squared in parentheses raised to the power of 4. So this power of 4 has to be put towards this 2, and it has to also be put towards this a squared. So 2 to the power of 4 makes 16, and a squared, and that to the power of 4 makes a, and we know it's a power to a power, so 2 times 4, which is going to give us now a total of 16, a to the power of 8. So again, we have this general rule for this as well. Our general rule is if we have a, b multiplied together, all of that in parentheses, raised to the power of m, again, we just are taking that exponent of the m and applying it, of this m, and applying it to what's inside that parentheses, which is why we get a to the power of m and b to the power of m. Here are 3 problems you can try now to apply this power to a power law. But before you go, take a look at letter C. Inside the parentheses, we have the decimal number 0.5. Now, if it makes it easier for you, remember that 0.5 can be represented as the fraction of 1/2. So if that makes it easier for you to use this law, then you can convert the decimal into a fraction. So complete these 3 problems for your next class. Bye, guys.